Hello everybody, and welcome to the PoorMansChemist. In this video, I am going to try to be making benzene again. I tried this yesterday from benzoic acid and copper chromite, and that was an unmitigated disaster. That completely failed. I got zero benzene from that shit. I'm not really sure why. I mean, I followed Doug's Lab's prep of pyridine from niacin beat for beat. It should have been nearly identical, but I don't know. The benzoic acid would just boil and come over into the condenser and, of course, condense back into a solid and clog the thing up like way too readily. At one point, man, I didn't realize what was happening at first because it was kind of foggy, and even with the prep we're about to do, it's going to get foggy inside the apparatus. So I didn't realize it was depositing like fucking layers of benzoic acid until I finally, I see it and it's like pure white. It's like, holy shit. Stop the whole thing, and I look, and my condenser looks like the arteries of somebody that's lived exclusively off like sticks of butter dipped in bacon fat. Man, I tell you what, that thing was nearly completely closed up. I mean, it wouldn't have blown up, or it just would have popped one of the stoppers off, but still, it's like, son of a bitch. And then getting it out of the condenser was a fucking nightmare. So yeah, that was a complete disaster. Anybody has any insight as to why that was a complete disaster? Please put that shit in the comments. I'd be very curious. Is it just that it just works better with niacin instead of benzoic acid? I would totally buy that explanation because, again, niacin has a higher boiling point than benzoic acid does, and maybe it just sublimates less readily and you can just get it hotter to where the reaction will actually fucking work. I don't know. I don't know what went wrong, but no matter. So like I said, we're gonna try Nile Red's method here, the one that he did a video on like 8 years ago before he became a giant pussy. And what we've got here on the right is 100 grams of sodium benzoate that I found that I forgot that I had. This is why I have to keep my chems on shelves. I can't put them in tubs or I'll start to forget all the shit that I have. And I don't want to keep lists. That's so goddamn tedious, and I always forget to update them anyway. On the left, we have 60 grams of sodium hydroxide. And we are going to combine those together, stir them up until they are an intimate mixture. Then we are going to transfer that to our handy dandy 1 liter round bottom flask. And then we're going to heat that shit up and really, really hope that this reaction will work. Niall used a propane flame when he did it. I mean, I don't have a metal container I can do this reaction in. This is basically all I got. So we're gonna really hope that my heating mantle can get this fucking thing hot enough to where it's actually gonna work. It does get pretty goddamn hot. I mean, it maxes out the IR thermometer, so I don't know how hot it gets, but it's pretty goddamn toasty. If it works, it should simply be a matter of, distilling out the benzene from the reaction mixture, washing it, redistilling it, and then yay, we have some benzene. And why do we need benzene? Well, benzene is the solvent for our benzyl alcohol to benzaldehyde reaction that we're doing with barium manganate. The paper calls for bare minimum at the amounts it's written for, and which are the only appreciable amounts, we need 30 milliliters of benzene. But this is all the benzene that I've got, and it ain't 30 milliliters. It's not far off, but it's not quite there. And I'd really like that prep to work. I mean, we're only going to get about 1 gram of benzaldehyde if we use 30 mils of benzene. That's what the paper is written for. And that'd be great if I had smaller glassware, but I don't. I'd really rather get like a few grams of benzaldehyde rather than just like 1 or slightly less. I can still prove that I made benzaldehyde using Brady's reagent, but again, it would just be nicer if I could get a few grams of it and we could demonstrate that it can indeed be scaled up and is in fact a practical method for the prep of benzaldehyde on a small scale. Or at least we can find out if it is, right? For all you naughty little kitties out there. Anywho, so I'm going to mix this shit together, get it in there, I'll get everything all set up, and I will come back when we're ready to get this party started. Alright, people, here we go. I'll try it at about half of maximum there, and we'll see what that gets us. Fingers crossed. Probably going to have to wrap this in some foil to insulate it. Maybe, I don't know. Let's see if we can get the reaction even happen first. Alright, people. I don't believe it. Look at that shit. Just like what Niall said in his video is happening here. Let's hope to Christ it's not fucking benzoic acid clogging up the fucking condenser this time. Oh, I see a drop of liquid. Holy butt fucking shit, is this actually fucking working? After 2 fucking days, have the chem gods decided to grant me my heart's desire, or is this just fucking water? Is this residual water? Man, don't be residual water, you fucking whore. Oh no, the temperature on it's like 40 C. What the fuck is this? Okay. Well, I don't know, guys. Look at this shit. So, our receiver is like the entire apparatus is filled with like some white smoke. If we were doing an alchemical operation, this would be a good sign. But I don't think that this really qualifies. Okay. Let's see, reaction mixture is bubbly and blackening. Come on, thermometer, we're all waiting on you to hit 80 C. Come on, you fucking whore. Do it. Damn you. Give me distillate. This is not a request. It's already going to be enough of a bitch cleaning this thing out later on. Okay, so as the reaction was winding down, I had to crank the voltage up. It's up near maximum now. I can see the black shit in the reaction flask bubbling. Maybe I can actually get it on camera here. I don't know. Probably not. Probably not with my hand shaking the camera all over the place. Oh well. But nevertheless, we are still getting distillate. Like I said, the amount of distillate coming over dropped off to, we're just getting a drop every few seconds. So I cranked it back up and she's producing again, but I don't know, maybe as you could have seen there, if you could make out what's in the flask, it looks like it's starting to wind down. Everything is turning into gray sludge in there, so I think we're getting to be a little close to the end here. Yay! Well, we've got more proof that the reaction worked. One of the products of the reaction is sodium carbonate, and I don't know if you can hear it or not, but I'm cleaning out the flask with concentrated HCl, and it is just fizzing away merrily in there. So if it was unreacted sodium hydroxide, it wouldn't fizz. Yay, it worked! I'm so happy. All right, everybody. So I have learned one thing about doing this prep. If you do it in glass, it will destroy your glassware. So yesterday I first did this in my 1 liter round bottom, and after it had cooled down, I noticed that there's a big ass crack across the bottom of it. I thought maybe it had a small crack in it already, and maybe just because it was so strongly heated and then allowed to cool down, that caused the crack to expand. I really hate it because that was a gift, man. Sorry, Eddie. It got a lot of use behind the scenes, man, like making nitric acid and stuff, but it didn't get a whole lot of use on camera. I feel bad about that. But anyway, so I was cautious. I mean, this is like the oldest round bottom flask that I have. I've had it longer than I've actually had a channel. And you focus, piece of shit. And so I checked it very thoroughly for any kind of cracks, both before and after the reaction was done, and it was fine. I was very careful to let it cool slowly and gently so that, not to shock the glass by adding water to it when it's still, screaming hot. And yeah, this is what I've come to find today. It is completely destroyed. So, 2 round bottom flasks are now gone and have to be replaced. Yay. Everybody's starting to see why this is such expensive content to make. So yeah, my advice is, unless you can find a way to get the hot melt out of the glass without cracking it, like right after the prep is done, I don't know how you do this without it wrecking the glassware. I mean, the first time it did it, okay, it's a fluke. The second time, nah, man. So yeah. I mean, the prep will work. It'll work just fine. The reaction will be fine. The glass will hold up through the reaction, but there's no way to get the waste product out of there, and it seems to actually bond to the glass, and I think that's where the problem really is coming from. I mean, obviously the glass and the residual solid, which is mostly sodium carbonate, will have different they'll expand and contract with changes in temperatures at different rates. So this is either pushing on the glass or pulling on it, depending on which one expands or contracts more, and it just caused the glass to crack. God damn it, man. Fucking A. Well, thankfully we did get a fair amount of benzene, so let's go ahead and let's do the workup and purification on that shit, and yeah, pour one out for my 2 round bottom flasks. Fucking A. All right, so here is our crude benzene. I don't know if this is going to show up or not, but I let this sit overnight last night and it settled out. There's another little layer there towards the bottom. I believe that's water. That doesn't surprise me. I mean, it wasn't completely anhydrous. We will have to deal with that at some point, which I've got a way where I think that will work to do that, because a tiny amount of water will dissolve in benzene, and we need our benzene to be dry for the experiment we want to use it for. Focus, you piece of crap. All right, so let's transfer it first to a SEP funnel. Let's make sure our stopcock is closed first before we do this. Lost 2 fucking flasks over this shit. We're gonna make sure we don't lose a drop of this mess. Okay. Wow, we got a fair bit. Cool. We're going to wash it with water anyway, so we can use water to rinse it into there. Oh, smell of benzene. Blah. people. We've got everything set up for simple distillation, so hopefully this will just be a matter of distilling this stuff over and we will be done. So I will come back once that is finished. Okay, so I have had this puzzling little problem. My distillate is coming over looking slightly cloudy, looking for all the world like it's some kind of hydrosol. Even though I extracted it twice with brine, it doesn't look like all of the water has been removed. I hope it is showing up. Let's see, maybe it's a little better from over here. Yeah, there we go. That's a little bit better. You can see it's distilling over. The boiling point is a little bit below 80 degrees C, which is what we want to hit. Now, this thermometer is, plus or minus 2 degrees, but it's still decidedly below. I don't know. According to Google, you can't separate benzene and water by distillation because they form an azeotrope, which that would explain what we've got going on here and why the distillate looks a little cloudy. I'm thinking that, just hitting it with a little anhydrous mag sulfate and either just filtering it or redistilling it will probably take care of the problem. So I don't think this is necessarily a big deal. And see, what's interesting here, though, is that now this throws a monkey wrench into my explanation because our filtrate is clear now after this distillation has been going on for a while. So either all the water was removed, in which case, why is the boiling point still slightly low? Or, I don't know. Maybe my thermometer has more of an error than is advertised. Maybe that's the straight benzene. If so, that would mean that, well, I would think that would mean that the water had been removed because there wasn't a lot of it. In which case, yeah, anhydrous mag sulfate should solve this problem. Well, welcome to real life chemistry, kiddies. It's never straightforward. There's always something, man. At least I knew what to look for. All right, everyone, here is our final product. So I was right. There was some water in it. I added some anhydrous magnesium sulfate to the distillate, and lo and behold, I don't know if that's showing up well or not, but some of it clumped up. If the anhydrous magnesium sulfate clumps up, there's water in your hydrocarbon. So there was some water in there. However, as you can see, there is still free-flowing anhydrous magnesium sulfate in there, so all of the water should be sequestered at this point. At this point, we could redistill it or probably just filter off the mag sulfate and call it a day, right? So what I'll do is I will just store this over this stuff until I am ready to use it for the benzaldehyde prep, and we will be good to go. This is the residue that was left over. This orange shit, as I have come to discover, can be a real bitch. It will not wash off with soap and water. However, I have found that ethyl acetate dissolves it readily. So you can completely and easily clean up your glassware from this orange crap just by hitting it with some ethyl acetate. So very convenient, which of course you can buy at the hardware store as MEK substitute. So it is cheap, readily available in bulk, and it will clean that orange shit off your glassware there, the benzo jizz. So anyway, there we go. Yeah, we got about 150 mils of this stuff, so once we filter it off, I don't know, we'll probably have about 110-ish mils. I will put the yield calculation there on the screen. If it's low, just remember, this was my first time, so, Anyway, if you like that video, give it a thumbs up, subscribe, comment, share the video. Please donate a few bucks, because I've got to replace 2 round bottom flasks now, and the chemicals that I used. God, this is expensive. Anyway, it's fun though. Until the next one, you guys, I see you later. Yay, I did it. I'm so happy.